All right, guys, welcome to Lab 15. We're going to pick up where we left off, where we were talking about systems of equations. Except we're going to be looking at three variables. Looking at the very first question for A and B, it says, for the following systems, determine if the given numbers satisfy the system. So our given numbers are 1, 2, and 3. So all we have to do for this, it's nice and simple, plug them in. But here's the thing, plug them into each one. So we're just going to systematically go through and replace x, y, and z with these numbers. So we have 1 plus 2 times 2 minus 3. And we're going to see if it equals 2. 1 plus 4 is 5. 5 minus 3 is 2. So we get 2 equals 2. So that one works. But we're always going to check the other ones too. So we get 2 times 1, 2 times 2, plus 2 times 3, and we're seeing if it equals 12. So that's 2 plus 4, and then, so that's 6, and then 6 plus 6 is 12. So 12 does equal 12, so that one works. So we have to try one more. 1 minus 2 plus 2 times 3, and we're going to see if it equals 5. 1 minus 2 is -1. -1 plus 6 is 5. So 5 does equal 5. So that one works. So in this case, to finish my problem, I'm not just going to do check marks. I'm going to say that yes, they satisfy. All right, now move on to question B. We're given 0, -1, and 4. So very carefully, I'm going to go in and I'm going to replace the variables with my numbers. So 2 times 0 plus 2 times -1 plus 2 times 4. And we're seeing if it equals 4. You can easily plug that first part into your calculator and then see if you get an answer of 4, but I'm just doing it in my head. 2 times 0 is 0, -2 plus 8, -2 plus 8 is actually 6. So we know that the very first one, right off the bat, we know that 6 does not equal 4. Therefore, just right there, not even having to do anything else, the moment that I get one that does not work, I know, no, they do not satisfy. All right, you could continue through and doing the other two problems, but once I get one that does not work, it completely throws out the rest of them. All right, for 2, obviously we're going to start using elimination to start solving our systems of 3 inequalities. But here's the thing, whenever you're doing 3, you need to cancel, you're going to choose a variable, and you're going to make sure that everything that you do, you cancel out that variable, but you can only work with 2 equations at a time. So I'm actually going to choose my very first ones. I'm going to look at the first one and the last one. And I know that I'm going to have to, I'm going to choose that y. I'm going to try to cancel out the y by multiplying it by a -3. So that becomes a positive 6y so that they will cancel out. So now distribute that -3. So we will get a -9x plus 6y minus 15z equals a -6. Nice and simple. All right, so then I'm actually going to take and I'm going to move that 5x minus 6y plus 4z equals 13. He did not have to change because I already know that that 6y and -6y are going to cancel out exactly like I need them to. So I'm going to start doing -9x plus 5x is -4x. -15 plus 4z is -11z. And this becomes 13, -6, 13, positive 7. Okay. So I got my very first reduced system. So now I'm going to choose a different one. So I'm actually going to choose the first 2. All right, so I know that in order to work these, to make that 7y and 2y cancel each other out, I'm going to multiply the top by 7. So I'm multiplying everything on the top by 7. I'm going to multiply everything on the bottom by -2. So I'm going to do my work over here to the side. Notice I'm actually using separate colors so that I can keep them separated from each other and follow along with what I'm doing. So I'm going to distribute the 7 to the top. So I will get 21x minus 14y plus 35z equals 7 times 2 is 14. Now I distribute that -2, so I get -8x, positive 14y, positive 2z equals 19 times the -2 is -38. All right, draw my line. I know that my y's should cancel out because I need both of them to cancel out. So I'm going to do 21 minus 8 to get a 13x. This becomes a plus 37z equals a -24. All right, so I have xz. So I'm actually going to take and bring my previous equation down so that I can then start working on those two. So I get -14x minus 11z equals 7. Okay, so now, sadly, in order to do these, I'm going to have to change both the top and the bottom. So I'm actually going to choose just my x's to cancel each other out since they're already opposites. So I'm going to multiply the top times 4 and I'm multiplying the bottom times 13. Now, the work, I'm going to bring it up here. That way I don't run out of space. 4 times 13 is going to give me 52x. 4 times 37 is going to be 148z equals -96. All right, now I'm going to distribute that 13. So I'm going to get a -52x minus 143z, and this equals 91. All right, so my x's are going to cancel each other out, which is exactly what I needed, and I'm left with my z's. 148 minus 143 is going to be a 5z equals a -5. So I knew z has to be -1. Awesome. So I'm actually going to choose one of my functions that has just x and z in it already, and I'm going to plug that z in. So I'm going to choose that very first one that I did. So I have -4x minus 11z equals 7. Oops. And I'm going to plug that -1 in and see what I get. So -4x minus 11 times -1 equals 7. -4x plus 11 equals 7. Move the 11. -4x equals -4. So x must be a positive 1. So I have my z. I have an x. Now I need to just do my y. So what I'm going to do is I'm going to have to go back to an original that has y in it. And I'm going to plug in that x and that z that I got. So I'm just going to choose the very first one. And I'm going to come over here because I'm running out of space. And I'm going to do 3 times that 1 that I got for x minus 2y plus 5. And instead of z, I'm going to put a -1. And it equals 2. 3, -5, that becomes a -2y minus 2 when I reduce and combine like terms. Add 2, this becomes -2y equals 4, so y must be a -2. I have my third one. Now when I go to write my answer, I'm going to come over here to the side. I have x, y, and z are equal to 1, negative 2, negative 1. And that is my final answer. Okay, so now we're going to move on to systems of linear inequalities, which means we're going to be graphing inequalities. So if you remember looking at the very first one, right, if we have a less than or a greater than, we know that we're going to use a dashed line. Less than, I shade below. Greater than, I shade above. So we're going to start graphing. I have 3x minus 1. I know when I graph, I'm going to start at negative 1. I'm going to go up 3 over 1, up 3 over 1, up 3 over 1. All right, and in reverse, I'm going to go down 3 over 1, down 3 over 1. All right, and I'm going to use my handy dandy ruler to help me draw my dashed line, all nice and neat. Remember, for it to be a complete line on my graph, it needs to have its arrows at the end. Now, this is y less than 3x minus 1, meaning it's going to be everything that is below my line. Now, if you are still having a very serious issue with figuring out what is above, what side is below, well, I have a handy dandy little thing for you that I'm going to show you. This is a resource that I love. It's called Desmos.com. So you're going to go to Desmos.com and you're going to go to the graphing calculator. And in your graphing calculator, you can hit the little keyboard and you're going to put in y less than, we have 3x minus 1. And you're going to look at it and you're going to compare to what you got right there. They should look the same, but it is a nice way to double check your work. All right. So we graphed our very first one. So question 3 we did. Question 4, I'm going to choose a different color. We want to do y is less than negative 2x plus 1. Less than. Y is greater than negative 2x plus 1. So I'm going to start at 1. That negative 2x means I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. And of course, I'm going to go up 2 over 1, up 2 over 1. And then I'm going to take my handy dandy little ruler. And of course, I'm going to draw my dashed line all along my points. Remember, I'm going to put my arrows. All right. And then it says what is y greater than. So it's everything that's going to be above my line. Remember, if you can't figure that out, go to Desmos and plug it in. Now, for question 5, we're going to do y greater than or equal to. So remember, when you're doing greater than or equal to, less than or equal to, you're going to have a solid line. Remember, solid line means that it's included. If an answer falls on that line, it is included. Remember, if it's a dashed, it's not included. So we're going to start with a positive 3. So we're going to go up 3. And we're going to go down 1 over 1. Down 1 over 1. And I'm going to go in reverse. 2, 3. All right, doesn't matter as long as you get a good idea of what it is so that you can draw a nice pretty line. And remember, it's going to be a solid line because it is greater than or equal to. Draw your line. Remember, add your arrows. And it's everything that is greater than or equal to greater than or equal to negative x plus 3, which means it's going to be everything that is above my line. For 6, I'm going to start at negative 2. So I'm going to start at negative 2. And I'm going to go up 3 over 1, up 3 over 1. Remember, I'm getting that up 3 over 1 from my m. So up 3 over 1. And I'm always going to go in reverse, down 3 over 1, down 3 over 1. And I'm going to take my handy dandy ruler and I am going to draw my solid line along, and I'm going to draw my arrows, and it is greater than, or sorry, less than or equal to. So it's everything that is going to be below my line. How do I know it's below my line? If I were to take my line and quite literally take it and draw it horizontally, it's everything that would be below where I moved. All right, so question 7 actually wants us to take, and we want to combine the equations for -3 and -4. So for my number 3, I had y less than 3x minus 1. And for number 4, I had y greater than -2x plus 1. Okay, so now we're going to take everything that we did and we're going to combine it into one. I'm doing mine in separate colors just so that you can follow along. So we start at -1, we went up 3 over 1, up 3 over 1, and of course down, oops. We also went down 3 over 1, down 3 over 1. So take my ruler, or my straight edge, whatever you have, it doesn't have to be a ruler, and I'm going to make sure that I draw my dashed line. Remember, it is a dashed line. Oops. And I'm going to put my arrows. Now, it is everything that was less than 3x minus 1, so it's going to be everything that was below my line. Now, whenever I do this, actually, I'm going to move to my pencil. When I do this, I'm going to very lightly take my pencil and I'm going to fill it in. Very lightly. Now I'm going to do my -2x plus 1. So plus 1, so it starts at 1, goes down 2 over 1. Down 2 over 1. I'm going to go up 2 over 1. Draw my line. So draw my dashed line and put my arrows. Oh, where did my little eraser go? Okay, so if for my red one, it was everything that was below the line. And for my green one, it's everything that occurs above the line. And what we're doing is we're looking, where are they going to overlap? So where they overlap is actually where I'm going to take, and I'm going to fill in heavily. So this is the area in which they overlap, meaning everything that is in that area is part of a solution for both of them. Now, once I've shaded in that area, I erase the areas that I do not need. That way there is no confusion, and this is my solution set. Now it says, do the individual linear equation inequalities intersect? Well, yes, they do. Now it didn't tell me to calculate, but you can always plug them into your calculator into y equals and calculate them. For B, it says, what does the intersection of the two individual inequalities mean? Well, it just means that they have multiple solutions that occur in the shaded area. Sorry about my handwriting, guys. Now it says, is 6, -3 in the intersection of the two individual inequalities? Well, in order to figure that out, we're actually going to have to take it and we're going to have to graph it. So I have 6, 1, 2, 3, 4, 5, 6, down 3, 1, 2, 3. All right. 6, -3 is roughly there. Now, if that point occurs in the overlapping shaded area, then that means that it is that means that it is a solution. All right, so we can say yes, 6, -3 is in the solution set. Meaning it satisfies both inequalities. All right, so now for 5. We're going to do, question 8, we're going to look at 5 and 6. So we're going to do y is greater than or equal to negative x plus 3 from question 5. And then we're going to do y less than or equal to 3x minus 2. All right, so we're going to start at 3. 1, 2, 3. And of course, we went down 1 over 1. And then we went up 1 over 1. And then we used our straight edge to draw a solid line. Oop. As I move everything around, I apologize, guys. So we're going to draw our solid line. And then we're going to add our arrows at the end. Now for the green, we start at negative 2, so down 2. We're going to go up 3 over 1, up 3, 1, 2, 3 over 1. I'm going to take my straight edge, and I'm going to draw another solid line with my arrows. All right, so I said y is greater than or equal to negative x plus 3. So greater than or equal to negative x plus 3, well, that's everything that's above my red line. So then I have y is less than or equal to 3x minus 2. So I need everything that is below my green line. So I'm going to take and I'm going to shade in the area that they overlap, which happens to be this little corner piece on the right. And I'm going to erase everything else I do not need. Now remember, you have a little resource, right? You can come over here to Desmos. I'm going to put it where I can see it. We're going to exit out the last one. And we're going to put y greater than or equal to negative x plus 3. All right, so we have our shaded area for that one. Now for equation 2, we're going to put in, we're going to put in y less than or equal to 3x minus 2. All right, take a look at it. Compare it to the one that we did and see, do they overlap? All right, well, that's the shaded area exactly like we got. So remember, Desmos.com is a great resource. Please use it. So now we're going to answer some questions about it. It says, do the individual linear inequalities intersect? Yes. Yes, they do. What does the intersection of the two individual inequalities mean? Well, exactly like we said in our previous problem, everything in the shaded area is a solution. So that's what we'll put. Everything in the shaded area is a solution. Now it asked, is 6, negative 3 in the intersection? Well, let's go take a look. 6, negative 3. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3. Ooh, if we notice something, it lands on my solid line. Because it's a solid line, we can actually say, yes, it is included. If that were a dashed line, that would not be the case. We would say, no, it is not a solution. But in this case, we can say, yes, 6, negative 3 satisfies both inequalities. All right.